So as I said, yesterday we learned about the transformation, the vertical and horizontal, vertical compression and vertical stretch, which dealt with the A values, the value that is multiplied by the x squared, right? And we called it A. So it's A times x squared. Today we're going to look at two other transformation, okay, which either you're adding to the x squared or you're adding to the x under the square. So we're going to look at two things today. We're going to look at something that this, what happens if I add a value to the x squared, or what happens if I add or subtract a value to the x. Okay, so two different transformation, and then at the end we're going to look at the combination of all of them. Okay, so the first one we're going to look at the addition of a value to the x squared. Okay, so what happens if I have y equals x squared plus a value or minus a value? Okay, so as I did yesterday, we're going to use Desmos, okay, to graph things, and then we're going to compare what's happening to my graph. Okay, what do you guys recall about y equals x squared, which is the parent function? What do we recall about that? Where's the vertex for y equals x squared? 0, 0. Which way does it open? Up, right? We recall this. And then the step pattern is 1, 3, 5. Okay? So the question is today, what happens if I have y equals x squared plus 2? So what's my k value here? 2. So I'm adding 2 to my function. Okay? So my k value is 2. So let's look at what's going to happen to my graph if I add 2. So what happened now? It was raised. I heard raised. It starts at 2. So the vertex went up 2. What value of the vertex went up 2? The x value or the y value? The y value, right? So you see that now my vertex is not at 0, 0 anymore. What's my vertex now? 0, 2. Okay? So that 2 caused the graph to go up 2 units. Okay. So let's see if that's going to be, the case every single time we add something to the x squared. So what's my second function? So x squared plus 4. Where's my function now? Where's my graph? It's higher again. Where is it? Where is the vertex? 0, 4. So it went up from the original one. We always compare to the original. Okay? We never compare to this one, for example, to the blue one. Okay? We always compare to the original. We see that from the original it went up 4. Right? And the reason why it went up 4 is because I'm adding 4 to my original function. Okay?
Just because k is 4?
Just because k is 4. Right? So what happened is the vertex, what value of the vertex changed? What did we say? You told me that which value of the vertex changed, the x or the y? The y, right? So what you see here is the vertex for this one is 0, 2. The vertex for this one is 0, 0. The vertex for this one is 0, 4. So we see that the y value of the vertex is changing. So k is affecting the y value of the vertex. Okay? What's the next equation? Y equals what? X squared minus 1. So what do you expect to see? if I type y equals x squared minus 1?
Might go down. Reflection.
Are you going to see a reflection? So you're going to see something that looks like this? Oops. You're going to see something that looks like this? What causes the reflection? If a is negative, right? In this case, it's going to be y equal x squared minus 1, right? So there's not going to be a reflection because I don't have a negative here, right? Okay, so then what do you expect to happen? Where is it going to start? Where's my vertex? 0, negative 1. So I'm expecting a vertex to be here, right? And then which way is it going to open? It's going to open up, right? Because my a value is still 1. My a value didn't change, okay? The value here is still positive 1. It did not change. So the only thing that changes is my vertex. So let's see if that's what's going to happen. Right? Exactly what we expected. So what's your vertex for this one? 0, negative 1. And what's your last? What's your last equation? X squared minus 3. Again, we're expecting it to be starting at or having a vertex at 0, minus 3. Okay? They're all opening up. The k value doesn't change the direction of opening. It doesn't even change your step pattern, right? Because if I look at my step pattern, right here, I'm going to go from negative 3. I'm going to go up 1 over 1 for my next point. Then I'm going to go up 1, 2, 3 over 1 for my next point. Then up 5 over 1 for my next point. So my step pattern doesn't change. My step pattern stays 1, 3, 5. Okay? But what's changing is where does it start? Where is the vertex? So, we said that the value of k for x squared plus 2 is 2. With direction of opening? Up. What was my vertex? 0, 2. Axis of symmetry? 0. It did not change, right? If I go back here, and if I want to draw an axis of symmetry, it's going to be right down the middle for all of them. It doesn't change. And remember that the axis of symmetry is what value of the vertex? What did we say yesterday? The x value. Okay, so how can you describe the shape of this compared to the original one? What kind of transformation I had?
Vertical stretch.
Vertical.
Compression.
No, it won't be stretch or compression.
Flex.
It's going to be vertical translation. That's what we call it. The word is translation. Okay? How many units in this case? How many units did it go? 2 units. Which way? Up or down? Up. So it's a vertical translation. Two units up. So this is how you state the transformation. Okay? And that's why they're right here. You just have to decide. Okay, x squared plus 4. What's the k value? The direction of opening? Vertex? Axis of symmetry? And then vertical translation. How many units? 4 units up. Can't make it any bigger nor colorful.
Maybe it never made sense until now.
How about the D? Y equals x squared minus 1. What's the k value? Negative 1. Direction of opening is up. Vertex? And vertical translation? 1 unit down. Okay? The down takes care of the minus. Okay? So when I say 1 unit down, it takes care of that negative that you see there.
Do we put like VD so it's like vertically descending? No?
No.
Alright.
Why do you want to make it too many?
Try it. It confuses me sometimes. VD is like transcend. You know what I mean?
Translation. That's a word. Translation. Okay, and then the last one, k is negative 3. Direction of opening still up. The vertex is 0, negative 3. The axis of symmetry does not change. And it's a vertical translation, 3 units down. Are we okay with this? Any questions? So, how does the value of k affect the basic parabola? When k is greater than 0, the parabola shifts up. When k is less than 0, the parabola shifts down. The value of k describes the vertical translation of the parabola. It's known as the, what am I trying to say here? It's known as the, no VD. It's known as the optimal value, I'm guessing, because it's changing the optimal value. Or the y value of the vertex. So let's look at the first example. So the question will give you the equation and will ask you to state transformation first. So what kind of transformation I have here? So y equals x squared plus 3. What kind of transformation I have? Vertical translation, 3 units up. Good. So this is the only transformation I have. Yes? Okay. So after I state the transformation, I'm going to have to graph. And to graph, I need to know the vertex, and I need to know my step pattern, because this is the way I'm going to graph at this point of time. This is the only way I know how to graph. Okay? So for me to be able to graph this, I have to state the vertex. Now, this is not part of the transformation. Okay? This is extra stuff that I need to know to be able to graph. So what's my vertex here? 0, 3. Right? Because we said that the k value affects the y value of the vertex. Good. Now, step pattern? 1, 3, 5. Are they going to be any different? No, because what's my A here? 1. And the only time the step pattern are going to be affected if A is other than 1. So, vertex is at 0, 3. You guys see that I include values on my x and y axis, and this is what's required from you on a test as well. I will not give you any marks on the graph if you don't have values on the x and the y. I want to know what your scale is. So if you don't have these values, the 1, 2, 3, 4, and whatever, I will not, I will give you a 0 on the graph. Okay? Because the scale could be whatever. You could choose your scale. So it could be you're going up by 10. How would I know? So, vertex is, where's my vertex? 0, 3, so it's right here. Is that right? Okay. Then to find my next point, what do I do? Up 1 over 1. So I'm going to, because that's what my step pattern says. My step pattern says I have to go up 1 over to both sides 1. So up 1 over 1. What would be my next point? Up 3. So from that point that I just drew, I'm going to go up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Right? My next point is going to be going up 5 over 1, but I'm not going to be able to fit it on the graph, so that's fine. 5 points is great. Okay? I'm looking always for 5 clear points. In this case, the vertex has to be one of them, and then 2 sets. Okay? So you see that I can graph this, and I'm always looking for that extension with the arrows. It's part of your graph. Because that tells me that you know that this is not going to stop here. It's going to keep going. Is that clear?
So the 5, because we add the x2 plus x3.
You mean this one? No, because this is your step pattern. So your step pattern for any quadratic is a times 1, 3, 5.
It's like
It's always a times 1, 3, 5. A in this case is 1. So it's always 1, 3, 5 multiplied by the a value. Okay? So you always start at your vertex, you go up 1 over 1. Then you're going to go up 3 over 1. Then you're going to go up 5 over 1. This is your step pattern. How about the second example? So I have y equals x squared minus 2. What is my transformation?
Vertical transformation. 2
Vertical.
units down.
Vertical translation 2 units down. That's correct. Vertical translation 2 units down. So this is my transformation. Now I need to include other information so I can graph. What do I need?
Vertex.
What's my vertex?
0, y negative.
So 0, negative 2.
Step A is 1, 2, 5.
So the step pattern is 1, 3, 5. It's not going to be affected, right? Perfect. So oh, these are positive, sorry. So where is my vertex? 0, negative 2. 0, negative 2, so it's going to be 0, negative 2, so it's going to be right here. And then where do I go from there? Up 1 over 1, right? So up 1 over 1 to both sides, right? And then from that point, I'm going to have to go up 3. So that's 1, 2, 3 over 1. So I'm going to end up here, 1, 2, 3 over 1. Can I fit one more? Let's see. 1, 2, 3, 4, 5. Yes. So 5 over 1. So that's going to end up here. So you see, in this case, I was able to fit all points that I